let's kick things off with a question that might be on everybody's mind. AI has been the theme of this conference. And one thing that comes along with that is a fear that robots are going to take our jobs. How concerned should we be about this? Chunyuan, you want to kick us off?
Yeah, this question has been existing for more than 40, 50 years since industrial robot was invented. At that time, of course, if you remember, it was in the US and Europe. The union was strongly against. The headline in the newspaper, the robot take our job. But today, if you look at those countries, has very high robot density, like Germany, for example, Japan, South Korea, as an example, their unemployment rate is very, very low. So this discussion, actually, it's very much. On the other hand, it doesn't mean robot will not replace the jobs. Of course, the robot will replace a job which human does not want to do, the dangerous job, absolutely, the boring job, etc. But the more important, improve the competitiveness of the company, and which makes the companies stronger and better.
Arnaud, are we rapidly approaching obsolescence?
I mean, from the drone perspective, an example that I like to bring up often is they're going where we cannot go or we can't go fast enough. You know, a lot of the work that's being done today is around inspection of critical infrastructure. And the feedback we get from the market is that the world has built so much infrastructure that we don't have enough people to inspect it. And if you take an example of a water dam, the penstock, which is a huge chute where the water is coming in at a very high pressure, if that concrete is showing any kind of signs of weaknesses, you're risking a complete catastrophic failure. And so drones can get there very quickly where a normal inspection can actually take weeks or months. So in that sense, you are sort of replacing the person who's going to go and climb on that scaffolding, but for the better of absolutely everyone.
Backstage, you had a fun little acronym for this. You called it the 3Ds.
Yeah, absolutely.
Explain what that is.
So the 3Ds in robotics the most efficient placement for all the jobs robotics is taking over are the dull, the dirty, and the dangerous. And in the drone industry, there's a very big focus on the dirty and the dangerous, specifically the dangerous, for both optimization problem or critical problem like the one I mentioned with the penstock.
And Bill, where do you stand on this? Are humans going to be overtaken by machines in the near future?
Well, I'm not worried about this, I think. This has been a long debate. I mean, with the technologies getting better and better, robotics technologies getting into smart manufacturing everywhere, I think that just improved the way people, design and manufacture everything. And eventually, the low-skilled workers will move to the higher, more sophisticated works. So that actually, I think eventually that just improved the efficiency and productivity. So to me, I'm not worried about that.
So you do have some products here. We're going to get to that in a little bit. But first, I want to ask another few questions just about the manufacturing process in general. Chunyuan, you are building a new factory in Shanghai. And it's going to be a factory of the future where robots are building other robots. Can you talk to us about how this factory is going to be different from the sorts of factories you operate now?
Oh, okay, thank you. ABB Robotics is one of the global leaders in the market, and we have been present in more than 53 countries, and China is one of our most important markets. And we have been in China since '94, one of the first, actually, the international player come to the market. And today we have a full value chain from not only the manufacturing, but also R&D, of course, sales, engineering, service. And our factory in Shanghai, we have a factory already in Shanghai. We built it 10 years ago. I was one of the person joined this project. And today, this is one of the largest in our group, but we see the needs to expand our capacity further. Then when we thought about, we want to build a factory for the future, in the sense because we are talking a lot about smart manufacturing. Smart manufacturing is not only about robotics, it's about, actually, in my opinion, it's about the digitalization, it's about the collaboration, and also about the simplification. When particularly in the discrete, you need to look at I guess Bill knows also, my panelists, they know very well, in the manufacturing, you need to think about the material flow, information flow, and action. What the robot is replacing is action, but what you really need to sort about is the information flow and the material flow. So we would like to build up a factory with a new concept, like a lot of islands, smart islands, and where we connect with the network, of course, information flow will be highly coordinated, and also we need to solve the problem of material flow. So this is our part of our experiments.
So instead of having a rigid sort of assembly line, you're talking about having these kinds of islands within the factory,
yes.
and it's more flexible
yes.
In terms of the way the product flows around the floor.
We really would like to increase ultimately the flexibility, because we believe the traditional, in the manufacturing, there's the one school, you say the bigger the better, the volume. And this part is true. There where you find the sweet spot and we get the cost competitiveness. But with the new technology, I think the sweet spot of the large volume will shift into the lower volume, more variance, this is where the consumer wants. So with the new technology, we can make it more efficient and cost competitive.
So speaking of flexibility, Bill, you are building a new factory in Shenzhen where you're building your flexible displays, which you've brought here. But before we show the flexible displays, maybe you can tell us how you're going about building this factory from the ground up.
You know, we started a company about 6 years ago with the focus on the flexible, fully flexible displays and the flexible sensors. We call it flexible electronics altogether. And the main difference is now you have to manufacture millions of transistors, circuits, sensors on top of a super thin, sometimes could be transparent, flexible film. And that is actually very, very different from traditional manufacturing compared to like silicon chips or rigid circuit board. So we have to start it from the basic materials, process, device design, circuit design, to eventually the product design. And then in 2014, we introduced the 0.01 millimeter flexible display. That's literally the thinnest flexible display in the world. And then we have to think about how we can do the mass production. But there is no reference in the industry at all, I mean, for the fully flexible display, which is different from the curved display. So we have to design the whole factory by ourselves. We started from, it's sort of started from ground, and then we design the factory, the layout. And we use a lot of automation technologies and digital technologies to design everything for the process, because we think that is the key for for today's manufacturing, especially like for the high precision device. You have to avoid like the contamination and from the air or from the dust. So we have to keep the fab really clean, and then we try to design everything from the digital mindset. So we spend a lot of money, on the software, on the IT infrastructure. And today, actually, if you go to our fab, it's mostly automated manufacturing, and with very, very few people working around. And today, the fab is already under mass production in Shenzhen. So we spent almost 2 years, had over 6,000 workers on the ground. And now the total investment is about $1.7 billion for the fully flexible display. So that's the display.
Let's see it. Show us what this is all about.
Yeah, sure. So here is the flexible display produced from our mass production line. As you can see, it's just super thin, it's super flexible, and it's very high resolution. So to show you how thin it is, this is actually thinner than the paper. But if you see the image or video, it's very high resolution. So we have millions of transistors, circuits on top, and there are actually tens of different materials, micro and nano materials on top. It's very difficult to make it happen. And with this, I mean, it's really difficult to build up the fab. And later, we put this into many different applications. So today, I also have another product actually based on the flexible display here. So it's in my pocket.
So we'd love to see it.
Yeah, this looks like a traditional smartphone, right? But the cool thing is, it's not just a smartphone. It's actually, this is a smartphone. But then the cool thing is, now you can actually open it up, and this will be a pad. So it's basically, now this device, it's a combination of a traditional tablet and a pad and a smartphone.
Very good.
Pretty amazing.
So this is based on the flexible display technologies. I mean, to make this happen, the manufacturing is really difficult. First of all, I mean, we have to do a lot of work on the sensors, on the displays, on top of this. And then also we have to do a lot of smart manufacturing on the product design. I mean, think about the hinge, the mechanical components here. It's very difficult, and it's very different from traditional smartphone design.
When my iPhone bends, it's usually not designed to do that. It's pretty impressive. But my question to you is, how did you and your startup manage to achieve this milestone that other tech giants were unable to? You know, Samsung, LG, all of them, I'm sure, are quite interested in designing very similar devices.
Well, I would say innovation and focus is the key. So for us, I mean, we started almost everything from ground. We have no reference for the materials, process, circuit design. We have to design everything by ourselves. I mean, keep innovative on everything. That's the key. And then the second is being focused on what you are doing. So we have been focusing on the flexible display technologies for a really long time. I mean, we started from the idea many years ago, and then in 2012, when we started the company, we just put all of the resources into the fully flexible displays. For now today, it's over 6 years, and now finally we made the mass production a reality, and also the product a reality.
Arnaud, do you have a drone that you can fly around for us?
I wish I had one, but it's it's an often point that's brought up when I'm on stage. The reality with drones is that when you're very comfortable with them, they can fly above your head and you feel okay with it, and it sounds great on paper, it's visual, it's attractive. But most of you would be pretty terrified to have even like one of the smallest one that we have, no matter how quiet they are, so no, I didn't bring one.
Well, so tell me a little bit about how your drones might be applied to the manufacturing process.
So what we're seeing beyond just manufacturing is people are extremely excited about drones and their capacity because they're this very powerful robot that is carrying all sorts of sensors, and today they're very much absorbing information, and they can go in all sorts of kind of environments. So we do have people who are approaching us to start discussing how could they be used in a variety of environments, including manufacturing. Now, it can be used as something as relatable as a security system, where you could have this patrolling in the area autonomously or semi-autonomously or even piloted, because the power of a drone in an enterprise setup is that it's capable of giving you very quickly an idea of what's going on at a fairly large scale. You know, it's very much bridging the gap between having an airplane or a full-size helicopter and having people patrolling on foot or on cars, for instance. But even on a factory floor, you could imagine them being used as a way of displacing elements, although it might not be very much pragmatic. And this is the part where this particular context is being explored. But if you look at them into other scenarios, even indoors, I'm not mean to bang on the penstock one, but it's very much a scenario where the drones are coming from the outside and coming inside. And it's all about bringing the technology to enable this kind of navigation, which is, to go back on AI, very high-driven.
Chunyuan, have you considered adding drones inside of the factory you're building in Shanghai?
Not yet, but I agree with Alan. Drone will have a key role to play in the future smart manufacturing because it's obvious it provides ultimate flexibility, whether you bring the information and the material flow. So, and also, of course, they can do a lot of emergency reaction. Very, very flexible. So it's just it's evolution. I think it's, but yes, definitely it will play the key role, but not tomorrow, but a little bit longer run.
What are the technologies you're most excited about putting into action?
No, the technology I'm most excited about, when we talk about smart manufacturing, it's really we are talking about two things. First, those equipments, the products inside the factory needs to be digitalized. When we talk about digitalized, it's not about just put the sensor and communication. Just to take in the factory, you have electrical motors everywhere, right? By definition, they don't need to be digitalized. They don't need to communicate to anywhere. But if you want to really digitalize your factory, you need to digitalize this motor, just as an example. And it's not just put in the sensor, get some information, it's really get a digital footprint. It's just one example. You have a lot of such equipment. So that's number one. Number two, I already talked about the manufacturing process. I believe it will be network enabled. That there is a lot of ways we can do. By doing so, then you can apply this latest technology, like many people talk about AI, etc., where we see there are two areas you can improve the manufacturing. Number one, the good use of AI can improve the quality and productivity within the manufacturing, but of course, eventually can also bring the business model change. So there is a lot of new technology we need to work on, and there are steps people need to think about to collaborate with academia, industry, and also the government authorities to really work on a new, good framework to make it happen.
How involved will humans be in the loop here?
No, human will play a key role because as this history just proved, right, we are on the fourth industrial revolution. Each technology revolution, it brings more wealthy and engage more people. I'm less worried about that. But it does not mean we have to defend and keep on our old job, to death. And that will be not the right attitude. So we need to evolve. So that's why we need to also here, that's why I mentioned the government has a very important role to bring the people, educate the people. You talk about the factory. Some factory job will disappear. You don't even find the people, but you need to create the new jobs and new skills, even more important.
So I want to open the floor up in just a few moments, but first, Bill, I have a question for you about your devices. They're very sexy, they're very cool, but maybe you can articulate for us the use of them. Like, why are they more useful than this phone that I have right here that's rigid?
Well, think about 10 years ago when Apple launched the iPhone. I mean, people initially thought it's just a change of the display. But actually today, when you look back, I mean, it's actually a change of the human-machine interface, change the way people interact with the information. So the whole hardware, software, operating system, and even business model is changed. That's what we call smartphone age and also the mobile internet age today. Now for this, I mean, this is not a change of the display itself. I mean, this is a change of the way people interact with the information too. Yes. Well, people used to carry a smartphone, a pad, a tablet, because people want portability and also large screen visual experience. That's just kind of a natural demand from the human. But then traditional smartphone give you portability, but they can't give you the large screen visual experience. For tablet and pad, they can't give the portability. Now with this, with FlexPi, you can actually combine the portability from the smartphone and the large screen visual experience into a single device. And also, it's actually, you only have to pay once to get functions from all of the functions from the traditional device. And this will also change the way people design the software and operating system. So it's actually an ecosystem. And eventually, I think mobile internet and the internet will be just one thing because of the combination of this device. Now you can combine the traditional user experience from the PC, tablet, we call it internet, and the experience from the smartphone, we call it mobile internet, all into a single device. So this is going to be huge. I think this will change the whole ecosystem.
Wonderful. Well, do we have any questions in the audience? Right up here, Ben. Maybe you can introduce yourself and.
Hi, Ben from Rich Glory Entertainment. That's a very cool gadget. My question is very simple. Can you fold it 2 times, vertically and horizontally? 2 times, because I want a bigger screen.
It's a very good question. Right now, we fold it one way. Along the way, I think there could be a lot more form factors. So this is just the beginning. This is just the beginning. And actually, FlexPi was launched in October in Beijing. And this is actually the first foldable smartphone built based on the flexible display in the world. And now it's also selling online. So we actually keep improving the form factors along the way. Definitely, I think there will be big screens along the way, for sure.
We have other questions? Anyone? OK. Arnaud, I've got a question for you. We've talked about some of these sort of consumer applications for these foldable, flexible devices. But how about drones? What are you most excited about? Are you more excited about consumer applications or business-to-business, enterprise, commercial sorts of functions?
Very personally, I'm much more excited about enterprise applications. And I'll give you a scenario. I mean, when we go back a little bit talking about, our machine is going to replace people, I see the world very, my personal vision, that people are not being used for what they're really capable of doing. People are very flexible, very smart, very creative, very adaptable into all sorts of situations. But we are also facing problems in the world that are bigger than people. And I'm going to take something very close to the chest and very recent, which is the Campfire in California. Biggest fire in California history. Half of California covered in smoke. You couldn't breathe. You couldn't do anything. And we are supporting a lot of effort to put our drones in these scenarios when they can really, really help. And the feedback we get from the field is that, for instance, during this fire, nothing is flying at night. And there's this idea that is kind of obsessing me, is that we could put these drones to fight fires actively. Imagine a fleet of 1,000, 2,000, 3,000 drones who would be carrying a small amount of water but would never stop bringing that water as a constant chain. I actually call this idea the aerial aqueduct, and I'm trying to push forward. At DJI, we are building the foundation technology for people to create all sorts of applications. We give you the hardware, we give you the software, we give you the sensor fusion, the processing, the stable navigation in a way that you don't have to worry about this. But this is the kind of application that would be absolutely phenomenal. You could deploy that fleet, bring it close to a water source, or to any kind of other element that you want to bring, a fire retardant. You could bring CO2 canisters to try to put down whatever is going to make sense on that moment. But the key point here is that technology could be flying and fighting that fire 24/7. They don't get tired. They never stop. They can be coordinated at a very large scale. They can travel long distances. They can stay in the air. They can coordinate. They can avoid automatically aircrafts. They can avoid the trees. They can avoid absolutely everything. Because we are bringing all these technologies, and there's a huge ecosystem. This is my favorite enterprise application, but there's a huge panel from opportunities that are applicable today and that have dramatic potential tomorrow. And what I really love the most about the drone technology is that, unlike the things you can see on Silicon Valley TV show, you really have people coming to you and telling you how much it changes their lives in a very, very positive way. And once again, back to these 3Ds, the dull, the dirty, and dangerous. Taking something closer to the chest and simple. A wind turbine inspection, which is trying to avoid a catastrophic failure. And if you go online, you'll see a lot of these videos of these wind turbines, like where the blade breaks down and starts flying somewhere. The way to do it today with people is to climb up that tower and rappel down on the road. It is a dangerous situation. So this is what I'm the most excited about. The consumer aspect is definitely interesting, but I see a tremendous amount of opportunity on the enterprise sector, and we're definitely making everything we can to solve as many of the problems to enable a huge ecosystem globally to tackle these opportunities.
It seems there's this incredible application to do the jobs that we don't want to put humans at risk doing.
Yes.
This sort of just jumped into my mind while you were speaking about the wildfires in California. This is my first time in China, and one thing I've noticed is the air quality of some of the cities is not so great. There's a smog that hangs over it. Chunyuan, ABB builds energy grids. How are we going to be powering these new factories of the future?
Well, ABB is providing, as you said, power grids, electrifications, and automations. And for our power grid business, one of our key technology is bring the renewable energies to any place you want. Because
moving away from the fossil fuels that produce.
Yes. Because normally where the place you have renewable energy, it's not necessary you have the very highest demand. So with our technology like high voltage DC lighting, controllable technologies, we can bring the renewable technologies. Just latest technology project we are working with China is China will host the Winter Olympic outside Beijing. There we will build these renewable grids with the DC technologies. So there's a lot of things we can do.
And another question I'd like to jump to is this idea that automation may exacerbate a wealth gap. As some of the low-end jobs get taken away, you might get the upper crust getting more value and more wealth that's not distributed evenly. How do you think about this issue and resolving it?
I think you talk about two different things, right? One is your technology will improve the productivity, which will create more wealthy for the society and enterprise as a whole. And does not mean the individuals or one group of the employment get more rich than others. I think that's a different question because there are different ways to distribute the wealth. And the society also has a lot of regulations and methodologies to distribute. For me, really most important to make sure our people, today their job is and will disappear, make sure we have a good way to transform them, to support them. For the future, education, etc., that will come. I'm less worried. Because think about what we need is a new skill. And we all went from school, right? From elementary school, primary school to high school. You need at least 9 years to finish the basic education. I hope it does not take 9 years to transform the existing generation to go to new skills. That's where we have a responsibility to make sure they can follow this.
Bill, so I want to ask something a little personal. After your company's most recent funding round, it put your net worth, at least on paper, at a couple $2 billion from the estimates that I've read. Is this wealth inequality issue something you think about?
Well, when we started the company, we had a clear mission, which is to improve the way people interact with the world using the flexible technologies. Talking about like valuation, market cap, we actually never thought about that in the beginning. Along the way, it's just kind of a natural process, a natural result. Even today, I never think about how kind of a market size, how kind of a market cap our company should be. For us, the main focus is on the technology and products and the service, to really realize the mission. So for us, the quality or the innovation is definitely the key, for the products.
So let's just go down the line in the last minute that we have left here, and I'd like to ask you each just for a quick prediction about what manufacturing is going to look like down the line, a couple years from now, 5 years from now. We can start with you, Arnaud.
So, the exposure they have towards manufacturing is something I can't really talk about, but if I have to say, like more on the robotics spectrum and how it's going to go, I think a lot of the robots are going to start taking over, like I mentioned, this 3Ds over and over again, and the pivoting question is going to be all around education. Is how do you get people to start picking up new kinds of jobs? Now, what I'm seeing around the drones world is that making a technology very easy to access, both because you take something complex and make it simple, and you make it affordable, gives an opportunity for a lot of people who are not necessarily technical to just pick it up and start getting on that scale. So I can very much see the same paradigm happening in manufacturing as well.
We have just a few seconds remaining, but if either of you care to share a prediction very quickly.
I believe manufacturing will be more distributed. Efficiency will be greatly improved.
And Bill, how about you?
Well, I think smart manufacturing is the key for the future of the technologies and the society. To make everything better, we have to start it from the very fundamental infrastructure. And smart manufacturing is definitely one of the main players.
Well, excellent. Thank you all so much for joining me here. Thank you all for tuning in. That's all we've got time for.